Hello guys, and welcome to my YouTube channel. In this video we are going to be talking about this small IC. This small IC here, if you check carefully, you see that the IC is small and long, and then you always see this small mark at the corner, this mark here, and the other mark at the opposite side. And you see that the IC is close to the charging IC. This is the charging IC. The IC is close to the charging IC. So this IC is the OVP, meaning over voltage protection. OVP, over voltage protection. So if you check the IC carefully, in order to identify this IC, if you don't have, let's say, a schematic diagram, so you want to identify this IC. If you check carefully, like I said, you always see some mark. There's a mark close at this side. You see the point. This mark at this side, and the opposite side, you likely always see this mark. And if you check carefully, you see that there are two capacitors. One is always at one end, and the other is on the other side. One is at the side which receives the voltage that is coming, and the other one is on the opposite side that is waiting. This small one here, that is waiting to receive the other voltage that will pass through the OVP. So they are like bodyguards. So this one stands to receive the voltage, and the other one is when it passes through the IC, it gets to the other capacitor. And then, if you check carefully, you see that the input voltage for when you plug your charger, the input voltage that is coming from the flex enters the motherboard here at this point. You can see that the point, I've catched the point, you see the point here. This is the input voltage, the VBOS. When you ever see this line that is big like this, you know that it's coming with the voltage is high, that is 5 volt. This point like this is the 5 volt point that enters through the flex into this upper board. Now, when you connect your phone to charge, the voltage that is coming may likely be like 5.10 volt. Let's say, for example, 5.10 volt. 5.10 volt. So that extra 0.10 volt. So when it enters, the voltage before it gets to the charging IC, which is this one, through this capacitor, as you can see here, it has to first of all pass through the OVP. So before the voltage gets to the charging IC, it has to pass through the OVP. This one, you see that the OVP is close to the charging IC. In some motherboard, it can be a little bit further. Now, what happens is, when that voltage gets to this capacitor, which has to, if you check the line closely, you see that this is a 5 volt line. You see that this is a 5 volt line here. So the voltage gets to this capacitor. So if the voltage is 5.10 volts, so what will happen is, this capacitor is going to receive that 5.10 volt that is coming from here, and then we'll pass it into this OVP, over voltage protection. And now this OVP is going to remove that 0.10 volt. So it's going to remove that 0.10 volt, that extra voltage, in order to get only the 5 volt that is required. And then you pass it into this capacitor, as you see here. That's why they are standing there. So this one takes the voltage, passes it to the OVP passes it to this capacitor. You can even see the connection. You can even see the line. From here, it enters this capacitor in order to go to the charging IC. So for those who have a schematic diagram, they can easily see it. So from there, it enters the IC. Now the IC is going to remove that extra voltage, 0.10 volt. So that only the required 5 volt is needed to pass into the capacitor here to the charging IC. Now what if this IC is bad? Because sometimes this IC could be faulty, could be damaged. Now if the IC is damaged, sometimes if you test, in some cases, if you have a short motherboard, if you test the voltage, that's the variables, the input 5 volt from this end, if you test it, and you see that this part is shorting, it may likely be this IC that is shorting, that's caused the short. So if you remove the IC and you don't have another one to replace, what you do is you just take a jumper. So if the IC is not there, you take a jumper from this point, you take a wire, you jumper it from this point to this capacitor. So you just jumper it from here to here, and everything will be working. So I hope you understand the function of this IC. If you want to identify, if you don't have a schematic diagram, in most cases you will likely see it like this. These two marked N, this N that is marked here and the opposite side, and then you always see two capacitors, one standing here and the other one on the opposite side. You can see it very clearly. One is standing there to receive the 5.10 volt, and the other is on the opposite side to receive the 5 volt that is coming, and then passes it. You can see the line into this capacitor to the IC. So I hope everything I said is understood. And now, if I want to check to see if this is the OVP that receives the voltage, I will need to put my multimeter. I'll need to put my multimeter to booster mode. Booster mode, then I'm going to take the reading. So if I check from that end, a scratch area, I check it. You see that there's a continuity, meaning that from here the voltage enters this capacitor. And in other way to check if the points are connected, what you can also do is you can take the reading. If I take the reading, let's take the reading and see. Let me take the reading of that point. It's giving us 3.90. Take the reading of that capacitor and see. It should be the same. Take it again and see. 388. Let's take it again. You see 388. You see that the readings are the same. In most cases, if you test these things like this, and you see that the reading are the same, this one has dropped again. The reading are the same, it may be likely that the points are connected. You see 3.7. When I test here, 3.7, 3.7, 3.8, 3.8. So if you test and you see that the readings are the same, in most cases those points are connected. So what you do, if in case there's an open circuit that the voltage from here is not getting, you have a charging problem, that the voltage from here is not getting to this guy, then what you can do is just jump a cable from here and link it to this. If there's an open circuit, just link a cable from here to this capacitor, and then everything will be working. I hope that is understood. Please subscribe to my YouTube channel and hit the like button for more interesting video, and so that we can take this channel from the basis to the professional level. I want to also thank all of you that have subscribed to my channel, and please continue to watch my videos so that we can grow this channel to the professional level. Thank you very much for your support, and see you in the next video.